So we've started a new unit. We are looking at bonding and naming of compounds, and we're going to start out with ionic compounds. Now, we talked about this in class today, but I want you to watch the videos many times as you need to and check out the skeleton notes to be sure that you got what you needed to out of this lesson. So the first thing you need to notice is that we're looking at ionic compounds. That means that this is a compound with this kind of adjective. They are ionic. And anytime you see ionic, you should be thinking that something here is going to have a positive or a negative charge, because that's what ions are. Ionic compounds are molecules where the components are held together by ionic bonds. And ionic bonds are essentially forces that hold together oppositely charged particles. So they are forces holding together, or really forces between, so we'll put that between oppositely charged particles. So many of you have already heard the whole idea of opposites attract. And so that is actually the thing that is behind this whole concept, is that opposites attract. So when you have a positively charged cation and a negatively charged anion, they are going to want to bond to one another. They're going to come near each other. They're going to be attracted to one another. And that bond that holds them together is ionic. Okay, so this is an ionic bond. Ionic bond in between a cation and an anion. So we're going to look at several examples of ionic compounds and how to determine what kind of compound it is based on the atoms that are involved. So the first one we'll look at is, and this is what we have looked at in class, so if you want some additional examples, feel free to check out the recommended reference pages in the text, and we'll do more practice in class tomorrow and on Friday. So if we're looking at lithium, the first thing that we need to do is determine where is it on the periodic table. It's in group 1. And how many valence electrons does it have? And lithium has 1 valence electron. So let's say in a single solution we have a bunch of lithium and we also have a bunch of fluorine. And again, we have to find where's fluorine on the periodic table. It is a halogen, so it has 7 valence electrons. And if you recall, fluorine is also the most electronegative atom. So it really very, very badly wants to steal an electron from somebody so that it has a completely full outer shell. Well, now it's in the same vicinity as this lithium, and lithium has this valence electron that it wants to get rid of. So this fluorine is going to pull this electron off of lithium and take the electron for itself. So that now we have lithium with 1 less electron, so it has a +1 charge. And we have this fluorine now with an extra electron, so it has a -1 charge. So now both of them are actually quite happy because lithium doesn't have this random outsider valence electron, and then fluorine fills the octet rule. It has all 8 electrons that it wants in its outermost shell. However, now we have these 2 characteristics. We've got this lithium with a positive charge and this fluorine with a negative charge. And keep in mind, opposites attract. So now, even though fluorine has stolen an electron from lithium, and they're both quite happy, now that they have opposite charges, they are going to bond to one another. So now that bond results in a compound where you have 1 lithium ion, one lithium ion and 1 fluorine ion, and this ultimately ends up being called lithium fluoride. And that IDE is an ending that you're going to see very, very frequently as we talk about ionic compounds and even covalent compounds, which will be a little bit later. So I want you to notice that we looked at these 2 atoms in their Lewis dot structure. We looked at their valence electrons and decided, okay, lithium is going to want to get rid of one, fluorine wants to take one. So then we looked at their ions, the ones that they're most likely to make. And then from there we looked at what kind of compound is it going to make. So since lithium has a +1 charge and fluorine has a -1 charge, you only need one of each atom to create a completely neutral compound. And that's something that you need to keep in mind, is that when you have ionic compounds, while the components are ions, the total compound has to be neutral. So these charges need to cancel one another out. And the fact that you had a +1 charge on lithium and a -1 charge on fluorine, they cancel out in this very neutral compound. So let's look at another example, one that we looked at in class today. And that was looking at sodium, Na. And again, sodium is in the same group or family as lithium, so it only has one valence electron. And we'll look at oxygen. So oxygen, if you look very carefully, it has 6 valence electrons. Now I want you to see that sodium, just like lithium, wants to get rid of that valence electron. It's really not happy having that one very random outsider electron. And oxygen wants to accept 2 electrons. It wants to pair this one up right here. It wants to pair this one up right there. So from this sodium, it's going to pull that electron. So now this sodium ends up being a cation with a +1 charge. And now this oxygen has a -1 charge, except the point here is that it still wants another electron. It's very, very greedy oxygen. So if this is in solution together, if this oxygen is in solution with sodium, keep in mind that there's many, many different atoms of each of these. So it's going to actually pull another electron off of it's going to pull an electron off of another sodium. So now you have these 2 sodium ions, because this sodium now becomes a cation as well. And it's happy that way because it doesn't have that floating single valence electron. It doesn't really want it. Now, this oxygen is also very happy because it has an octet. It stole this electron from this sodium over here and this electron from this sodium here. So now this oxygen has 8 electrons. But in this case, that means that this oxygen has a -2 charge. So what we're seeing here is that an oxygen with a -2 charge, the only way to have a compound with this and sodium is for the compound to have enough sodium to cancel out that -2 charge. Well, we've got the -2 on the oxygen here. We've got a +1 on this sodium and a +1 on this sodium. So a compound between sodium and oxygen is going to require 2 sodium ions for every 1 oxygen. So what it's going to end up looking like is Na2O. And that 2, that subscript, means that you have 2 sodiums. And the 1 is understood. We actually don't have to write a 1 in here because it's understood. It is, if it was 0, then you wouldn't have an O written there at all. But again, keep in mind, this is a neutral compound. So the positive charges on the sodiums are canceled out by the negative charge on this oxygen. And it always has to ultimately be neutral. Now, if we're going to name this compound, we're looking at the first part, the first atom, which is sodium. And notice that when you are writing out the chemical formula and writing out the name, the cation always comes first. And let's make a note of that. The cation always comes first. And we're going to see that over and over when we're naming and figuring out compounds later on. So we're going to write out sodium, and then the second, the anion, is oxygen. So we don't write sodium oxygen, we write sodium, and then we replace the end with IDE. So it's sodium oxide. Okay, so anytime that you see lithium fluoride, you need to be able to also go in reverse and say, oh, well, that's LiF. Anytime you see sodium oxide, you need to, again, be able to go in reverse from the name to the chemical formula, Na2O. So let's look at a couple of examples of how to go from the name to the chemical formula, and I'll do that in the next video.